Hello guys, my name is Siddharth Varde and this is Data Structure Fundamentals 2 Mat2 Answer9. So the first question is how to delete the kth node from the beginning in a singly linked list and in a doubly linked list, right? Okay, so I have prepared a diagram for this, and let's say this is a linked list A, B, C, D and E, singly linked list, and I need to delete the kth node, right? So currently the k is like let's say the third node, and if we look at it as an index, so 1, 2 and 3 would be as an not as an index, as a normal numbers, normal sequencing, then 1, 2 and 3, C would be my 3, right? But like, so I would run a loop for k times, right? And I would traverse in a linked list, but if I run out, like if I hit null, like if I hit the end of the linked list before the k ends, so like I have to say, look, we cannot delete it, right? So because, like, let's say if I have to delete the 7th node, and there are like only 5 nodes that exist, so I cannot reach the 7th node. That's why like I cannot do that. So let's assume that we are only deleting that node that exists, right? So what we need to do is we need to run a loop for k time, and what we need to do is we will start with the we need 2 pointers, right? One is node and another one is previous node. So previous node starting value would be null, and node starting value would be head, so it's A. So now in the first iteration, what I would do is like previous node is equal to the current node, right? The node that we want to delete, not exactly the want to delete, like the current node. Okay, so like it would be head, and my current node will become the next node of my current node, right? So like my like current node will become B in the first iteration. So n points towards B, previous node is A, and my current node is B. Then in second iteration, same thing happens, that my previous node becomes B and my current node becomes C, and we say, okay, we have reached the number 3, right? So like we have reached the node that we want to delete. So like 1, 2 and 3, like we have reached the third number. So that's why like at that point what we say is previous nodes, like the B is the previous node's next node is equal to current node's next node, right? Current node's next node is D, so B's next would become D, and now we can say delete the C, right? Because like now if we try to traverse, then A to B, B to D, D to E, C is deleted, right? And like here what is, like, not just like connecting them two together, like we are also deleting it, right? So like we are deallocating the memory. And what happens in doubly linked list, we don't need the previous node, so we would traverse from A to B to C, and like if same thing, if we run out of the linked list, then we say, okay, like we cannot delete it because we cannot reach it, right? So I would traverse 3 times, like so first time is an A, then B, then C. I would reach the C node, and when I reach the C node, what I need to say is like that my previous nodes, right? My previous node is B, so my previous node's next node, this pointer, will point towards my next node. So my next node is D, this, right? My next node is D, so it would point towards this, and my next node, that is D, that's my next node's previous node, then means this pointer, it will point towards my previous, so like it's B, right? So my next node will point towards my previous node, and like the current node's previous node, and my previous node's next node will point towards my next node, right? So like the current node's next node. So B would point towards D, D would point towards B, and then we can delete the C. So this is the process. So now if we try to traverse in forward direction, A to B, B to D, D to E, and E to D, D to B, B to A, so like the all list is intact and we have deleted the element successfully. Okay, so the second question is explain the real-time application of stacks. Okay, so the I would say the best example that I found is undo system. Okay, so let's say I'm creating a game where I can undo few moves, or maybe a lot of moves, depends on the game. But let's say I'm trying to say like undo, I'm trying to uh, I'm trying to create an undo functionality. So what I would do is I would take a stack, I would enter all the actions that my player took. Let's say he moved forward, then he moved backward, then even he moved forward 2 moves. So all those moves will be entered inside a stack, and when I say like undo it, so I would just pop out first move, okay, what happened, and make it reverse. So like if he moved forward, then I would say okay, move backward, right? Then if he moved backward, then I say okay, move forward. So like in that way I can just implement stack to perform an undo functionality. So that's an, I guess that's a awesome, uh, like that's a fantastic example of stack, I guess. Like at least that I think. Thank you, I guess. Goodbye.